This screencast is still in kinetics, and this one is focusing on mechanisms and molecularity. All right, so reactions do not always proceed as a reactant set straight to the product. A lot of times you will have multiple steps leading to the end overall reaction. If you remember back to thermochemistry, there were some times that we did, for instance, we did a reaction where we went from A to B, and then we went from B to C, and then C to D. But the overall reaction was the same as A to D. And what we did then was we added up all those steps. Reaction mechanisms are very much like that, and they get you the overall reaction. A couple of things here is that each step along the way, each one of these, is called an elementary step. And the elementary steps are single events. The overall reaction is considered to be the mechanism. When you have substances in between, for instance, the letter B, they're called intermediates. If they're formed in the middle of the steps and then eliminated before you get to the end, it's an intermediate. Now, one thing that I don't have listed here, and it might be on the next screen, is a catalyst. A catalyst speeds up the reaction, and it shows up in the first step, and then it'll reappear in the last step. Okay, and it's not actually part of the reaction. It is just there to speed up the reaction, but it is not used in the actual reaction. Some terms for reaction mechanisms, they talk about the molecularity, and that is basically the number of molecules that participate in the elementary step. So if you have one molecule, it's unimolecular. If you have two reactants, it's bi, and if you have three, it's trimolecular. And this, again, only applies to the elementary steps. All right, so if you have multiple steps, you really only have typically one of the steps that is the overall factor for how fast the reaction will go, and that is considered or called the rate determining step, and that is the slow step. The slow step is the overall best possible speed you have. So just like in a relay race, you can only go as fast as your slowest runner. So you will need to be looking for the slow reaction or the slow step when we look at mechanisms. One other thing to realize is that any elementary step, the coefficients are the order for the exponent, but this is only in elementary steps. If it's the overall reaction mechanism, then the coefficients don't matter, as we've learned before. But when you have it broken down into the elementary steps, then each step, the rate law for that is based on the coefficients. So we are going to look at how we determine by deciding which one's slow or fast. They will either tell you the steps are fast, fast, slow, or whatever, or you'll be asked to look at the reaction rate law and pick the slow step. Here's an example reaction mechanism. This one is not very detailed. It's pretty simple. Its coefficients are a 1, and for these would be your steps in your mechanism. They would be your elementary steps, and one of the two of them would be faster than the other. What you do is you add up the steps and you get the overall. Remember that you're canceling out intermediates, so O single is an intermediate, and you get your overall reaction. We will be looking at problems where they will give you the approximate speeds and ask you to pick how fast they are with some sample problems in class.